All right, today let's take a look at how related rates shows up in a few Pythagorean theorem questions. Okay, this is a common way to have related rates show up. So let's jump right into example 4. This is on the note sheet that you already have from Friday. So it says, the top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So let's just kind of sketch out this situation, right? I know that I've got a right triangle here, and this is my ladder, right? The ladder is sliding down the wall. So as this slides down, this is obviously going to slide out this way. So I know that this is going in this direction, and then this distance is increasing that way. So let's see. I can label my sides A, B, and C. That's just my preference whenever we're doing Pythagorean theorem. I mean, some people label it X, Y, Z. It's totally up to you. So I know that I'm going to relate this somehow using Pythagorean theorem. And I know that's going to be up here in my note, a squared plus b squared equals c squared. So now what I'm given, let's see, I'm given that the ladder is 25 feet. Right? So I know that c is 25. What else? I know that the ladder is sliding down the wall at a constant rate of 3 feet per minute. So that's this distance right here is changing at 3 feet per minute. Now, since this ladder is sliding down the wall, that rate we're going to say is negative, right? So I'm going to say that the rate that A is changing with respect to time is equal to -3 feet per minute. Right? Then, let's see, when the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So what I want to find, distance between the bottom of the ladder and the wall. So that's dB dt. My goal is to find dB dt when the top of the ladder is 7 feet from the ground. So when A equals 7. Now the reason I didn't put this up here in my given is because this is something that's changing, right? A is changing every second, but what we want to find is dB dt at the instant when A equals 7. Okay, so that's why I put it down here in my find. So let's start differentiating and see what we can figure out. So I know I'm going to have to take the derivative of this, and I'm going to have to implicitly differentiate all three of these variables. So what we end up with when I do that is 2a dA dt plus 2b dB dt equals 2c dC dt. Now, whenever I plug all of my stuff in, I should only have one thing that I need to solve for. Okay, so let's take a look at what we have. I know A is 7. I know dA dt is -3. I don't know B, right? I'm not given B anywhere here. dB dt is what I want to find. I know C, but I don't know dC dt. So right now I have 3 unknowns. Right? That's a problem. My only unknown should be dB dt. So we're going to have to do a little bit of work to figure out those other 2 things. Right? First, I don't know B. Well, this is a right triangle. Right? I know 2 sides. I know that C is 25, and I know that A is 7. I can use Pythagorean theorem to find my missing side. So I can say 7 squared plus b squared equals 25 squared, and solve. So 49 plus b squared equals 625. Subtract the 49 over, we get b squared equals 576. The square root of 576 is 24. Right? If you recognize right off the bat that this was a Pythagorean triple, good for you. Right? B would be 24. So I can now add that to my list of things that I know. Right? I know for sure that B is equal to 24. I don't want that. There we go. All right. Now, I've got one last thing I don't know. I don't know dc dt. Okay, well, dc dt is the rate at which c is changing, right? Well, c is the ladder. This length is not changing through the entire problem, right? This ladder is just sliding down. dc dt equals 0 because the length of the ladder is not changing. So now I have all the information I need. Right? I can plug everything in. So my a value is 7, dA dt is -3, plus 2 times b is 24, times dB dt equals 2 times 25 times 0. So let's see what we end up with here. 14 times -3 is -42, plus 2 times 24 is 48 dB dt equals 0. So if I add this 42 over, we've got 48 dB dt equals 42. Then divide both sides by 48, and we end up with dB dt is equal to 42 over 48. And remember, if this is a free response, we don't have to reduce, but I'm going to go ahead and reduce anyway. Both of these are divisible by, 8? So, I'm sorry, but they're both divisible by 6. So we get 7 over 8, and our units would be feet per minute. All right. Now, I should have put my units in here as we went, just to double check and make sure my final units were correct, but I did not. I forgot to do that. But we do need to make sure that we have our units tacked on at the end. Okay. So most of the time, when we have a Pythagorean theorem question, we will have to solve for one of the missing pieces over here. Right? We'll have to actually use the Pythagorean theorem to find a missing side. All right. Also, in Pythagorean theorem questions, it's common to have a negative rate of change. Right? We can say that one thing is moving in one direction, one thing's moving away. Right? So we have to make sure that we keep our positives and negatives straight when we're talking about rates of change. Okay? All right, let's take a look at the next one here. So here we have a couple of ships sailing in different directions. So let's see, we start out with just ship A is 150 kilometers east of ship B. Right? So you can say that ship A is right here, ship B is right here. Right? And they are 150 kilometers apart. Well, now it says ship A starts sailing west. So west would be this direction. And ship B starts sailing north. So ship B is going in this direction. And ship A is sailing at 35 kilometers an hour, and ship B is sailing north at 25 kilometers per hour. We want to figure out how fast the distance between the ships is changing at 4 p.m. So the distance between the ships, right, ship B is going to end up here. So I'm going to erase that label of B down here since ship B has now gone up here. That distance between the ships is going to be this distance right here, right? This diagonal distance, or the hypotenuse of my right triangle. So what we know we're going to have to relate these things using Pythagorean theorem. So a squared plus b squared equals c squared. What I'm given a couple of rates. Okay, I know that ship B is sailing west. I'm sorry, ship A is sailing west at 35 kilometers an hour. That's the rate at which this is changing. So I can say that if I'm going to call this side A, this side B, I'll call this side C. So the rate at which side A is changing, so dA dt, is equal to, now this distance is decreasing, right? So this is going to be a negative rate of change. This will be negative 35 kilometers per hour. My handwriting is struggling a little bit here. And I know that this rate is increasing, right? So I know that my dB dt is going to be a positive 25 kilometers per hour. All right. Now, we want to figure out the rate at which the distance between the ships is changing at 4 p.m. Right? So my goal is to find dC dt. Okay. Well, I've got a lot of things I don't know right now, but let's just take our derivative and see what all we need to find. Okay, so just like the last problem, my derivative will be 2a times dA dt plus 2b times dB dt equals 2c times dC dt. Okay, well, I know dA dt and I know dB dt, and I want to find dC dt. But right now, I don't know A, B, or C. So let's dive a little deeper into this problem. Okay, the piece of information that we were given is that at noon, this distance right here was 150 kilometers. Right, well, we want to figure out what's going on at 4 p.m. So that's 4 hours later. Well, if this ship is moving 35 kilometers per hour in this direction, after 4 hours, it will have traveled 140 kilometers in this direction, meaning all that's left here is 10 kilometers. Right? If this was 150 and I go 140 in this direction, all that's left at this instant is 10 kilometers. Okay? Similar idea here. Okay? If B started here and traveled 25 kilometers per hour for 4 hours, well, it traveled 100 kilometers. Okay, so A is 10, B is 100. I need to use the Pythagorean theorem to find C. So I can say 10 squared plus 100 squared equals C squared. And this one is not going to work out nicely. Right? This is not going to be a perfect square. So we just end up with C is equal to the square root of 10,100. Right? And we could simplify that a little bit, but we don't need to. Right? I'm not even going to bother doing that here. So we now have all the information we need. Right? We know A is 10, B is 100, C is the square root of 10,100. So I can plug everything in now. So A is 10. dA dt is negative 35 plus 2 times b is 100 times dB dt is 25 equals 2 times c, which is the square root of 10,100 times dc dt. All right, so let's see what we end up with over here. 20 times negative 35 is negative 700. Plus 200 times 25 is 5,000. Equals 2 times the square root of 10,100 dc dt. So we get 4,300 over here, and then in one step I'll go ahead and also divide by this. Right? So 4,300 over 2 times the square root of 10,100 is equal to dc dt. And my units would be kilometers per hour, right? Because we're just talking about the rate of change of a distance. Right? So if this were a calculator problem, I mean, we could put this into the calculator and get a decimal, but this is fair game to not be a calculator problem. Right? I mean, we just did all of that without a calculator. Right? We don't have to simplify this radical. We just get this big ugly fraction at the end. Okay? So yet again, we had to use Pythagorean theorem to find a missing piece, but in this one we also had to use a little bit of logic to figure out what these lengths would be. Right? We had to think about, well, 4 p.m. is 4 hours later, so how far would each of these ships have traveled in 4 hours? Right? Let's take a look at one more. Okay, this one showed up on the AP test in 2002. Right, so this one was a while ago, and this one is pretty similar to the one that we just looked at. Right? So let's dive in piece by piece here. Right? Let's just start with part A. Part A, well, let's read the whole question first. All right, ship A is traveling due west towards Lighthouse Rock at 15 kilometers per hour, so the ship's going in this direction. Ship B is traveling due north, so it's going this direction at a speed of 10 kilometers per hour. We're saying X is the distance between ship A and the lighthouse, and Y is the distance between ship B and the lighthouse at time T. So part A is just find the distance in kilometers between ship A and ship B. Right? Well, that's just Pythagorean theorem, right? So since they're using X, Y, I'll use Z here. So this is just saying X squared plus Y squared equals Z squared, right? So we know that X at this instant is 4. So 4 squared plus Y is 3. So 16 plus 9, we get 25, and we get that Z is equal to 5. All right? So make sure that we label this. All right? So our final answer should be Z is 5 kilometers. Right? And it might not even be a bad idea to write out, the distance between ship A and ship B at this instant is 5 kilometers. Right? Actually writing that out in a sentence. Now, since 2002, they have made the statement that questions like part A here will no longer be given points on the test because this didn't require any calculus. Right? This was a basic geometry problem. So you would still have to find this piece of information, to complete the problem. You just wouldn't be awarded points for it. In 2002, you were actually awarded points for it. Okay, so we need that piece of information to do the rest of the problem. So let's take a look at part B here. Okay, so part B is find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 and y equals 5. Right, so I know I'm going to have to use Pythagorean theorem here. I know x squared plus y squared equals z squared. So let's take our derivative. So we'll have 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, and let's list out everything we know. Okay, so we know at this instant x equals 4, y equals 3, and we found that z is 5. So dx dt, let's see, the rate at which ship A is moving. Ship A is moving towards the lighthouse at a speed of 15 kilometers per hour. That means this distance is decreasing, so that's going to be a negative 15 kilometers per hour. dy dt is traveling north at a rate of 10 kilometers per hour. So that's going to be a positive, right, because that distance is increasing. And then what I want to find is dz dt. So I have only one unknown. I can plug all these pieces of information in and solve. So we've got 2 times 4 times negative 15 plus 2 times 3 times 10 equals 2 times 5 times dz dt. So 2 times 4 times negative 15 gets us negative 120. And that would be plus 60 equals 10 dz dt. So we've got negative 60 equals 10 dz dt. And then I'm going to come over here and finish this out. So all I have to do is divide by 10. So negative 60 divided by 10 is negative 6. So we get dz dt is equal to negative 6 kilometers per hour. Okay. So again, we had to use Pythagorean theorem to find this missing piece, but in this case, they broke that into two separate pieces for us. All right. So let's take a look at part C here. There was actually a part C. Right. Part C is let theta be the angle shown in the figure. We want to find the rate of change of theta in radians per hour when x equals 4 and y equals 3. So here, I need to figure out some way to relate theta, y, and x. Right? This is something we haven't really taken a look at yet. But if I'm thinking about right triangle trigonometry, well, if I'm looking at this angle and these two sides, this would be the opposite side, this would be the adjacent side. So my function that would relate those would be tangent. I can say tangent of theta equals opposite over adjacent, which in this case would be y over x. Right? And then I can take the derivative of this piece. Right? Now, when I do that, derivative of tangent is secant squared. So I'll have secant squared of theta times d theta dt. Right? Theta is a variable here. Don't forget your d theta dt here. Now over here, we'll have to use quotient rule. So when I do quotient rule, I'll have x squared on the bottom, bring that x straight up, times the derivative of the numerator. Well, that'll be dy dt minus the derivative of the denominator, dx dt, times y. So now we have to come over here and figure out what all we know. All right? So we know that x is 4. We know that y is 3. We know that, let's see here, dx dt, right, from the last part of the problem, we already figured out that dx dt was this negative 15. We know dy dt is 10. What else do we need here? Well, we need secant squared, right? Because my goal is to find the rate of change of theta, right? I want to find d theta dt. But how on earth do I find secant squared? Well, all we have to do is think about our triangle, right? I know that the sides are 3, 4, 5. So secant is the reciprocal of cosine, right? Well, cosine of theta, in this case, is adjacent over hypotenuse, 4 over 5. So secant of theta, in this case, is 5 over 4. So let's plug all that information in. I'm going to make this a little bit thinner. So we've got 5 over 4 squared times d theta dt equals 4 times 10 minus a negative 15 times 3 all over 4 squared. So now we just have to do some arithmetic. So this would be 25 over 16 times d theta dt equals 40 minus a negative 45. So 40 plus 45 would be 85 over 16. So now I'm just going to multiply both sides by 16 over 25 times 16 over 25. So here, these cancel out. We get d theta dt by itself. And over here, the 16s cancel out. Right? Remember, we could just multiply straight across and then reduce, but we can cancel out common factors as we go. So I see those 16s will cancel out. And we could then just leave it as 85 over 25, but we can reduce that a little bit further. Obviously, both of those are divisible by 5. 85 divided by 5 gets us 17. So this is 17 over 5. Now, what on earth are my units? Right? Well, it even tells us in the question. Right? Find the rate of change of theta in radians per hour. Right? So we get 17 over 5 radians per hour for my final answer. Okay, this one was a little bit weird. This one was different, okay, for part C. But again, it was all about just finding some formula. 99% of the time it's a geometric formula, and again it was here, that relates everything in the situation. Okay, so be aware that trigonometric formulas could show up here as well, especially if we're dealing with angles. Right? Relating an angle with two sides could be tangent, sine, cosine. In this case it was tangent. Okay, so take a minute to look back at these. All right, we're going to do some practice on Khan Academy again. So if you want to get started with that now, more than welcome to, or you can wait until class tomorrow.